In this video, we're going to work part B of example problem 6. So I did leave all of the writing for part A, that way we can go back and reference it because we're going to need some of those values here to work part B. So part B says if the radius of the pipe narrows by 10% as it passes from one suburb to the other, what is the velocity of the water in the pipe now? So we're actually going to work all of the math on this clean slide here so that nothing gets confusing and in a totally different color. So we have a pipe, the underground. It narrows by 10%, so it gets smaller to a degree of 10%. And then the pipe is delivering water or whatever liquid it is to homes. And so the water is passing through the pipes like this. And so we know whenever we have two pipes and one gets smaller and one is bigger, that they're both going to have areas and that there's going to be velocities for the water traveling through each of these pipes. And so we know, just based on previous questions that we worked, that the formula we're going to be using is A1 squared V1 equals A2 squared V2. And so we know we're going to have a big pipe side. We know we're going to have a small pipe side. We know we're going to have an A1, a V1, an A2, and a V2. So the good thing is that A1 and V1, we already have that information. We calculated the area over here. So 0.00835 meters squared, and the velocity was given to us here. So 2.0 meters per second. It narrowed by 10%, so we have to take 10% of the first area. And to do that, you have to convert the percent into its decimal form, which is 0.10. So the way that you take a certain percent of a number is to multiply the number by the decimal form of the percent that you're trying to take from it. So to take 10% of 0.00835, we'll have to multiply that by 0.10 to get 10% of it. So in your calculators, 0.00835 times 0.1 equals 8.35 times 10 to the minus 4th meters squared. So that is going to be 10% of 0.00835. And to find out how much it narrowed by, we have to subtract this number from the original area. If it got bigger by 10%, we would add it, but it actually got smaller. It narrowed by 10%, so we have to subtract. So 0.00835 minus 8.35 times 10 to the minus 4. So in your calculators, 0.00835 minus 8.35 second e to the minus 4 is 0.0075 meters squared. So that is going to be our second area, 0.0075 meters squared. And so now we have everything that we need to calculate that last velocity. So we're going to go ahead and plug our numbers in. Don't forget to square your areas because the answer would be wrong. So 0.00835 squared is 6.97 times 10 to the minus 5 meters squared. For the velocities, we just bring them down. Nothing changes here. Equals, now we're going to take 0.0075 and square it. And it's going to be 5.625, so 5.61 or 5.63 times 10 to the minus 5th meters squared x. And you can use V2 if you would like to, either x or V2, it doesn't matter to me. So to get x by itself on the right side of the equal sign, we have to divide by 5.63 times 10 to the minus 5th meters squared. And that cancels. So again, bring it to the other side and divide by 5.63 times 10 to the 5th meters squared. Sorry, that's going to be to the minus 5th meters squared. So in your calculator, 6.97 second e to the minus 5 times 2 divided by 5.63 second e to the minus 5. And that is going to equal a V2 of 2.476 or 2.48 meters per second. If you go into the textbook and find this problem, it's worked a very different way. However, this is the way that I prefer to work it. It doesn't mean that I would mark it incorrect if you worked it the way that the textbook worked it. However, I think that this way makes more sense for me. So this is how I worked it. Thanks, and let me know if you have any questions about part A or part B of example problem 6.